Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem on Leetcode. The problem number is 129. The name of the problem is sum root to leaf numbers. You are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. Okay. For example, the root to leaf path 1, 2 and 3 represents the number 1, 2, 3. Return the total number of all root to leaf numbers. Leaf node is a node with no children. So let's look at some of the example and try to understand them in details. So the first example that we are given over here is a tree with 3 nodes where 1 is the root node and there are 2 leaf node 2 and 3, right? So from 1, if I try to reach the leaf node, so I can reach it like this. So I have touched only 2 nodes over here, 1 and 2, right? So this becomes the number 12. And if I try to reach the other leaf over here, which is 3, so I will touch only these 2 nodes over here, that is 1 and 3, right? So I'll get a number 13. So 1, 3, if I remove the comma, I just make that number 13, right? And if we add these two up, what we get is 25. And that's what we are looking for as an output as well, right? So let's understand with a little complex test case over here. So for this example, this tree has some complex nodes as well. So for this example, what we see is that the child node 9 has 2 childs as well, right? So if we first identify the leaf nodes over here, we'll see that 5, 1 and 0 are the 3 leaf nodes over here, right? So if I try to reach 0 from 4, the nodes that I'll end up touching is 4 and a 0, which gives me the number 40. And if I try to reach 1, then I'll be touching 4, 9 and 1. That's the shortest part, which will give me the number 491. And the shortest part to 5 is 495, right? Which will give me the number 495. So if I sum all these parts up, all these numbers up, what I get is 1026. And that is the result they are also looking for, right? As you can see that we have these 3 numbers, right? So we have to return an int at the end of this function to the calling function. And that is this program all about. So as I always recommend, do give it a try. Do try to solve this using some tree traversal algorithm, right? We have discussed a lot of tree traversal algorithm in this channel previously. Do check them out. I'll also leave a link to the description to all the tree traversal algorithm that we have discussed. So yeah, once you give it a try, do check out the video as well. So let's head over to the board and check out the solution, right? So what I have done is I have taken the same tree from the example, the second example that we have seen, and we are going to see how this is going to work and how we are going to solve it. So before we go into the tree, so you can understand that we will be having 3 nodes, right? 4, 9 and 5. And from 4, 9 and 5, what we need is to construct the number 495, right? So how do we do that in integers? So let's understand that first. So I will not go in much details. I'm just going to show you how it will work. For example, if we have an array of integers 4, 9 and 5 and we need the output 495, what we can do is we can take a variable val equals to 0. We iterate over the numbers and we use this. So basically what happens when let's say my val is 0, right, initially, and then we get the numbers, right? So the first number we get is a 4. So what we do is we do a val into 10 plus the number. So val is initially 0. So what will happen? The number is 0 into 10 plus 4, right? So we'll get a 4. So our val will become 4 now, right? And on the next time when we get the number 9, what we basically do is so our val is 4. So 4 into 10 plus 9. So it becomes 49. So it becomes 4, 9. And for the last number 5, when we get that number, we already have val is 49 into 10 plus 5, which is 495. So this is how we do it, right? So we are going to use this. So let's keep this aside for now, and we are going to see how this is going to help us in building the numbers, right? So what basically we are going to do is we are going to use a recursive function over here because that's the most common way of doing a tree traversal. So keeping this formula in mind, we are going to look at how we are going to leverage it. So let's say I pass a 4 to him, right? I pass my value to my next node. So what basically he does is he does the same thing, 4 into 10 plus I. So if I do a 4 into 10 plus I, what the value becomes over here is a 49, right? Now if I pass both of them a 49, right, what it does is it does a 49 into 10 plus the value of the node, right? So what I get is 49 into 10 plus 5, and here what I get is a 49 into 10 plus 1, right? And if you check over here, what happens is we get the value, right? And also I pass him a 4, right? Because my value is 4. So here what I do is 4 into 10 plus 0. So I return 40, right? So if you see over here, the value we got was 495 that we are looking for. Over here 491 that we are looking for, and over here we got the value 40 that we are looking for. So these are the three values that we need to sum it up, right? So our algorithm would look something like this. We're going to create a sum function which will take a node, right? And we will give him an initial sum, right? So when I call this sum function, what I'll be doing over here is the initial values that we are talking over here is the root of the tree, and we also have the sum, right? So sum, I haven't calculated the sum yet, so I'm going to pass a 0 over here, right? And now what this function will do is, of course, this node is null, it's going to return a 0, all that thing is fine. So basic intention of this function is to implement this formula that we have established over here, right? So what I'll do is I will do a value equals to whatever sum I have already received from my calling function. So over here we saw that we have passed 4. So what did he got? He got a 0 basically. So he used the same formula, 0 into 10 plus 4. So that's how he got that 4 that he has passed around. So this is how we have been calculating, right? So every step we get a function. So over here, as you see that we have got a 0, here also we got that same 0 that we are talking about, right? So we are going to put the same formula that we have been talking here, sum into 10 plus nodes value, whatever value it has, right? Let me just reconstruct the tree over here so that we can understand in more details. Now let's understand that we should return our sum, whatever sum we have from the leaf node, right? If we encounter a leaf node, we are going to return whatever value we have calculated so far. This is what we do at every step, right? So if we see that we have the leaf node, we return the value. Otherwise, we go down in the recursion. What happens is basically node points to the root of the tree, right? So let's take a node over here and try to understand how the node is going to traverse. So node is at this point, right? And what happens is we are calculating the value at this point of time. So in this stage, what happens is the value becomes, so the formula for calculating the value is the existing sum that we have got, which is 0 in this case, into 10. So 0 into 10 is a 0 plus whatever the node value is. So that is basically 4, because we have a value 4 over here. So let us put that over here. Now once we calculate the value, we are going to see that if it is a leaf node, if it has no child, we are going to return this value. So that means I have came down. So let's not go into the statement over here, since it is not a leaf. What we are going to do is we are going to go to the left. So the node will come over here and we are going to pass the value that we have calculated, right? So what happened basically was sum was 0. Sum is received as 0 over here, right? So over here what happened is sum is received as 4, right? And we are going to do the calculation based on this. So again, 4 into 10, which is 40 plus node's value. So what we get is a value 49 over here, right? And is it a leaf node? It's not a leaf node. So what we are going to do is we are going to call the go further left. It's mostly like a inorder traversal that we are doing. We are processing, then we are going left, then we are going right, right? Now what happens is we come over here, and what happens over here? We get the sum as 49 and we calculate the value. So the sum is 49 that we have received from this function. So these are basically the value, that is, sum is basically the value that was passed, right? So he got a 0. So he called him with a 4 and he called him with a 49, whatever was calculated at this stage, right? So 49 into 10, the same formula applies again, 49 into 10 plus the value. So what we get is a 495 over here. Now we are done with this part. So now we are done. So we hit a condition that it is a leaf node. We can't go any further, right? So what we do is we return the value that we have calculated. So let's put it with a different color to the calling function. So this is what has been returned. So if you remember, we have invoked the left side of this tree, right? This is what has been invoked. This right side is still pending. So when we call this again, we have the value 49, right? So what happens basically over here is the right side is called again with 49. So what happens over here? The sum we receive is 49 and we are going to calculate the value. So value, again applying the same formula, what we get is a 491, 49 into 10 plus 1. And we are going to return the same value because we see this is a leaf node, right? So we are going to return to this function over here a 491. Now what happens basically over here is we sum them up, 495 plus 491, and we return it to my calling function, right? So this has been called from the left hand side. So what happens over here is basically this guy over here returns 495 plus 491 to 4's left side. So this was the calculation going on for the left side. The right side is never invoked, right? It is going to be invoked now. So we send back a 986 over here, right? So this left is now ready. Force left is ready. Now force right need to be assessed, right? So what happens is 4 calls the right side with the value 4. Why 4? Because the value is calculated at 4. So what it becomes over here, the sum becomes 4, right? Because val becomes the sum, right? So we receive it in sum. And what happens over here, we recalculate the val. And when we do 4 into 10, which is 40 plus 0, so we return back a 40. So this function over here, it returns back to him a 40. And what he does is, he adds both of these, right? 986 and 40. So what he gets is a 1026. So whatever function we call, we return him back 1026. And which is the result that we wanted, right? So this is the solution all about. So what we are going to do is quickly move to the Leetcode and write down this recursive code, right? So basically we are not going to touch this function for the moment. What we are going to do is we are going to create this function that we have talked about. So we have the tree node over here and we'll call this node, and we are talking about a sum that will continuously get, right? So what happens over here, this guy calls me with the root and gives me the sum 0, right? Sorry, the method is missing. Yeah. So this is what happens basically. So at any point, if we see that the node is null, in that case, we are going to return back from this function a 0, right? Because the node itself is not there. We don't want to get into that state, right? And now what we are going to do is we are going to calculate the val, and the val is nothing but sum into 10 plus node.val, right? And now once we have the val ready, what we are going to check is it's a leaf node or not. So how do we know if a node is a leaf or not? Basically both the left and right should be null, right? So node.left and node.right, if that is null, we are going to just return the val back, right? That's what we have been doing all this while, right? And otherwise what we are going to do, we are going to return, we are going to use the same function, we are going to call it with the left first and pass the val, whatever we got, and we are going to process the right once the left is done. So yep, this is the entire solution, right? This is the entire solution. So just for we are going to put a preventive check over here. If root is null, then also we can return 0 directly. We don't need to do anything, right? So yeah, this is the solution all about, right? It's a pretty interesting, simple and concise solution that we have seen over here. Okay, so let's do something. Let's run the code and check how it goes. I guess I haven't. Okay, no mistakes. Thank God. Let's do a submit and check for the broader range of test cases. Yep, we are good. So the solution is pretty good. You can see it's like for all test cases, it took around 0 milliseconds. We have 100% submission. Means most of the people have submitted kind of same code. So again, once again, the solution could be easy, but what I wanted you to understand this thought process over here, how things are getting into shape, how this recursion and what is the meaning of the recursion and every details of it. So do let me know what do you think about the solution. If you have any questions or doubts or any improvement suggestion as well, please feel free to drop a comment in the section below. And even if you have got the solution, do let me know that what is your opinion on the solution. And before we end this video, let's talk about the complexity over here. So basically we are touching all the nodes over here. So if you see over here, we are touching all the nodes, right? So if you consider the stack space, then your space complexity is going to be order of n, right? Because in a skewed up tree, like if we have a tree something like this, so if you have something just like this, so you are going to take up all this stack space over here. But if you're excluding the stack space, then we are not consuming any extra memory, right? It's pretty much constant space that we have been dealing with. But yeah, in terms of runtime, we are touching all the nodes, so it will be order of n, where n is the total number of nodes in the tree. So for space, I'll say order of 1, excluding stack. So if I don't consider the stack space, where in many problems in Leetcode, what I say is that, okay, don't count the stack space, right? That's why I'm mentioning this. Otherwise, it could be order of n, where n is the total number of nodes. So for a skewed up tree like this, what will happen is you'll be ending up storing. In a skewed up tree like this, where you have 3 nodes, you will go into 3 levels into your recursion, right? So that's going to be your space. And for runtime, we'll be having order of n, where n is the number of nodes in the tree, right? So yeah, that's all from this video. Do let me know what you think about this video. If you're a first time viewer and if you haven't subscribed to the channel yet, feel free to subscribe. I try to publish videos every alternate day or every day. And also we are starting with some new topics very soon. Yeah, that's all from this video. Be safe. COVID is on rise. So I request all my viewers that please stay home, please stay safe. Let's get over this second wave and try to come out of it fine and healthy. Take care of your family members. Stay safe and spend your time in some creative things, programming or some DIY or some stuffs that you like. But please do stay at home. Don't go out. And that's all. Hope to see you guys soon again. Bye bye and take care.